Fine. Good morning. In the last class, we were discussing about the concept of humidity. We started with concept of humidity. We covered concept of pressure belt, concept of wind. What are the various type of wind? Warm local wind, cool local wind, as well as after that we covered the phenomena of temperature inversion. Different type of temperature inversion we have covered. Then finally we discussed the humidity concept. These are the concepts we have taken up in the last class. So where do you see the blowing of Sirocco wind? Sirocco in North Africa, moving towards where? Moving towards European region. Yeah, towards Spain, towards France, it is moving towards European region. It causes which problem? It causes which problem? Yeah, bloody rain. So it causes the soil to become infertile. Agriculture is difficult to do in those regions. And then we also discussed another one, which is the Harmattan. Harmattan is which type of wind? Harmattan is doctor's wind, beneficial wind that is moving from African region to what? African region to the coastal areas. Fine. We also discussed the other two wind like Chinook and Fawn, where Chinook is blowing North America, Fawn in Alp region. Fawn in Alp region. We also saw which wind has recently caused a wildfire in California. Santa Ana. Yes. So Santa Ana wind has recently caused a wildfire, huge wildfire in California region. Fine. So those are the warm local wind we have discussed. Which cold local wind is known for its violent gusty flow. Violent gusty flow. Cold local wind known for its violent gusty flow. It is blizzard. So it is blizzard, which is known as violent gusty flow. Then also we discussed what? We also discussed, apart from the blizzard, we have also discussed the other areas, like what are the air drainage type of temperature inversion? Where air drainage type of temperature inversion, where do you see air drainage? Yeah, in mountain areas. What is temperature inversion phenomena? Yeah. Yeah. The conditions are a long night. We discussed the second condition is what? The second condition is winter night need to be there. The third, calm air, and the fourth is stable weather. Those are, or clear sky, stable weather. Those four conditions are what necessary to form temperature inversion. And temperature inversion we have described as what? As you go up, temperature will increase. As you go up, temperature will increase. This phenomena is known as a temperature inversion. Normally, as you go up, temperature decreases, and what it is called as? It is called as a normal lapse rate. Yes, okay. As you go up, temperature decreases. It is called as a normal lapse rate. Fine. So finally, we started with the concept of humidity, and we discussed humidity is what? It is a moisture or water vapor present in air. How we have defined absolute humidity? Actual amount of water vapor present in the air is referred as absolute humidity. And we discussed that absolute humidity is measured as weight of water vapor divided by what? Weight of a water vapor divided by per unit volume of air. Weight of water vapor divided by per unit volume of air is referred as what? Is referred as absolute humidity. Fine. Now we are coming to the second part, which is relative humidity. What is relative humidity? So it is the amount of water vapor holded by air to its maximum capacity. to its maximum capacity. That is what we call as relative humidity. It is amount of water vapor holded by air to its maximum capacity. Fine. So if this, let's say, air can hold 100%, out of which currently there are 70% moisture. Currently there are 70% what air is holding. So this 70 divided by 100, this is what we call as a 70%. So currently what the air is holding, how much is its maximum capacity? When you divide that, you will get, okay, what you will get? Relative humidity. So relative humidity is defined as how? It is defined as amount of water vapor that currently air is holding and how much maximum it can hold. When you take this division, that is called as what? That is called as a relative humidity. Clear? Now, so that's why the formula for relative humidity is the moisture content in air divided by moisture holding capacity. So this is how we try to find the relative humidity. Moisture content currently in the air divided by the maximum moisture holding capacity it will have. This is how we calculate relative humidity. Fine. So as we discussed, when the relative humidity becomes 100%, what does it indicate? When relative humidity becomes 100% means moisture content in the air is 100, moisture holding capacity is also there. So what you see is maximum it is holding, then relative humidity becomes what? Relative humidity becomes 100%. So when relative humidity becomes 100%, then we call it as what? Saturated air. Then we call it as which type of air? Saturated air. So when air holds the moisture its maximum capacity, then such air is called as what? Saturated air. If relative humidity is less than 100%, then it is going to be called as a unsaturated air. Means there is a still chance that air can hold further moisture. So what you see is relative humidity is equals to 100%, then saturated air. Relative humidity is less than 100%, then it is going to be called as a unsaturated air. Fine. Fine. The temperature at which air becomes saturated is referred as dew point. This is referred as a dew point. So the temperature at which air becomes saturated is referred as what? Is referred as a dew point. Clear? So if question comes, what is dew point? Dew point is the temperature at which air becomes saturated. Fine. Dew point is the point it is the temperature at which air becomes saturated. That is referred as dew point. Fine. Let's say temperature is 30 degrees Celsius. Temperature is 30 degrees Celsius. Air temperature is 30 degrees Celsius. Now air is holding the moisture. And relative humidity is what? Relative humidity is 100%. So this temperature is going to be called as what? This temperature is going to be called as what? Dew point. At 30 degrees Celsius, air has holding moisture and relative humidity is how much? 100%. So the temperature at which air will become saturated is going to be called as what? Is going to be called as a dew point. Fine. Now, what will happen what will happen if you increase the temperature? If you increase the temperature, what will happen? So air was temperature was 30 degree. You saw the air becoming saturated. Now what is going to happen if you increase the temperature? Humidity also will increase. Anyone else? If you increase the temperature, what will happen?
Humidity.
Why it will decrease?
Because humidity is something contains moisture. Moisture content reduce.
Fine, moisture content may reduce. Any other reason? Any other reason? As we discussed, when you increase the temperature, what happens? We discussed what will happen. Volume will increase. Clear? When you increase the temperature, what will happen? Volume will increase, because we discussed volume is directly proportional to what? Temperature. You heat something, what will happen? Things will expand. So volume will expand. Fine. So when you are increasing the temperature, what will happen to the air? Air volume will expand. When air volume will expand, what will happen? Air now can hold what? Air now can hold more moisture. Earlier it was having less volume, so it can hold lesser moisture. But now volume is expanding, means what happen? What will happen? Air can now hold more moisture. When air can now hold more moisture, what will happen to relative humidity? It will decrease, because relative humidity is what? Moisture content by moisture holding capacity. When moisture holding capacity is increasing, then what will happen? Moisture holding capacity. Yes. So what you see is, when moisture holding capacity increases, then what will happen to relative humidity? It will decrease. Clear? So earlier, let's say we are just using the term. Let's say this is a air. It is having a volume of, let's say, 100 meter cube, and the moisture content that is present in the air is also nothing but this much. So what you see is, this is making the relative humidity how much percent? 100%. When volume will expand, what will happen? Moisture holding capacity will increase. When this will increase, what will happen to relative humidity? It will decrease, because it is inversely proportional. It is inversely proportional. So that's why relative humidity will decrease. So whenever we have to change relative humidity, whenever air becomes saturated, you can make it unsaturated by how? By heating. Yes. So you can make it unsaturated by increasing temperature. So relative humidity is also going to vary with what? Relative humidity is also going to vary with the temperature. It is also going to vary with the temperature. Fine. So how you can change the relative humidity? You can change the relative humidity by increasing the temperature, and that's why relative humidity is also going to vary with the temperature. Last class. Air, no, saturated air is when air do not have a capacity to hold moisture. Yeah, unsaturated air is what? Yeah, still having the capacity to hold the moisture. That is unsaturated air. When relative humidity becomes 100%, then it is going to be called as what? It is going to be called as a 100% saturated air. Fine. So one way you can change the relative humidity is by varying the temperature. What will happen if you vary the pressure? What will happen if you vary the pressure? Now you know that volume is inversely proportional to what? Pressure. Volume is inversely proportional to pressure. As you are increasing the pressure, what will happen? Compression will happen. Compression means volume will decrease. So if you are varying the pressure, then also what will happen? Relative humidity is going to change. So if either you are varying the temperature, relative humidity is going to change, or you are varying the pressure also, then also relative humidity is going to change, because in both cases what will change? In both cases volume will change. If volume will change, what will happen? Moisture holding capacity is going to change. Fine. Any doubt regarding this particular thing? So like we discussed, absolute humidity is varying with whom? Absolute humidity is varying with temperature and pressure. Like that, what will happen to relative humidity? It will also vary with temperature and pressure. Fine. And as we discussed, in normal weather, when we are making the weather prediction, etc., which type of humidity we are using? We are using the relative humidity. We are using the relative humidity. So weather bulletin and other bulletin are using which type of humidity? Relative humidity. Fine. So if you are getting a question, what is correct one? First one is correct. Wrong. So relative humidity decreases if there is an increase in temperature. We discussed, as you increase the temperature, what will happen to volume? It will increase. Volume increases means what? Moisture holding capacity increases. When moisture holding capacity increases, what will happen to relative humidity? It is going to decrease. So yes, this point is correct. Second, relative humidity increases if dew point is reduced. What is dew point? The point at which air becomes what? Saturated. The point at which air becomes saturated. So relative humidity is 100%. And it is happening at a certain temperature, which is 30 degrees Celsius. So this temperature is referred as what? This temperature is referred as a dew point. The temperature at which air becomes saturated is referred as a dew point. If you are reducing dew point, means you are decreasing temperature. From 30 you are coming to 29 or 28. If you are decreasing the dew point, means you are decreasing the temperature. When you decrease the temperature, what will happen? What will happen when you are decreasing the temperature? What will happen to volume? Volume will decrease. When volume will decrease, what will happen to moisture holding capacity? Moisture holding capacity will decrease. Moisture holding capacity is going to decrease. Clear? Any doubt regarding this one? So what will happen to relative humidity? It is going to increase, because inverse relation, when moisture holding capacity is decreasing, what will happen to relative humidity? It will increase. That is okay there. So that's why relative humidity increases with dew point. Clear? When dew point is being reduced, what will happen to relative humidity? It will increase. Fine. Any doubt regarding this particular part? So this is important aspect you have to keep in mind with regard to concept of relative absolute humidity. Now the third type of humidity is a specific humidity. Specific humidity. It is generally measured as a weight of water vapor expressed in gram to the weight of water vapor present in air expressed in gram to the weight of air So specific humidity is what? Specific humidity is being measured, expressed as a weight of water vapor to the weight of air. Fine. So what is the difference that you are finding between definition of absolute humidity and definition of specific humidity? definition of absolute humidity and definition of specific humidity. In absolute humidity also we are taking weight of what? Water vapor, but there it is compared with the volume of air, not compared with what? Weight of air. In absolute humidity we are comparing it with what? Volume of air, per unit volume of air. Here we are taking per unit weight of air. Clear? So here we are taking per unit weight of air rather than volume of air. So that difference lies between whom? That difference lies between absolute and specific humidity. Clear? So how much is the weight of this air? How much is the weight of this air? And how much the water vapor weight is there? When you take weight of both, weight of this water vapor that is present and weight of total air that is okay there, then it is called as what? Then it is going to be called as a specific humidity. Fine. So specific humidity, that's why formula to measure is what? Formula to measure is weight of water vapor divided by weight of air. Weight of water vapor divided by weight of air. This is referred as what? This is referred as a specific humidity. Fine. Fine. Now the question here is whether the specific humidity will also vary with temperature or pressure. As we discussed, both humidity, absolute humidity is also varying with temperature pressure change. We have discussed relative humidity is also varying with temperature and pressure change. Will specific humidity will also vary with temperature or pressure change or not? No. Why?
Because they're calculating how much of the weight is present.
Yes. So
There's no particular weight.
there's no particular weight. No, there is a particular weight. Like you know that air contain what? Air contain gases. Which are the gases? Carbon dioxide, hydrogen, oxygen, nitrogen. You know weight of air. You know weight of water vapor. How much air is holding. So why do you think whether it is not? Why do you think it is not going to vary with temperature and pressure?
Whatever the weight will be calculated.
Fine. Anyone else? Anyone else? Whether it will vary with temperature or pressure or not? The specific humidity does not vary with temperature and pressure because weight is not dependent on whom? Weight is not dependent on temperature and pressure. Earlier, why it was varying? Because volume was dependent on whom? Temperature and pressure. We discussed when temperature increases, what will happen to volume? Volume will increase. When temperature, when pressure is decreased, what will happen to volume? Volume will increase. So temperature, pressure were affecting the volume, and that's why the absolute humidity was changing and relative humidity was changing. But here we are not taking volume. Here what we are taking? Weight. And weight is independent of whom? Independent of variation in temperature and pressure. Weight is, how do you calculate weight? Weight is mass into gravity. This is your weight. How do you calculate weight? Weight is nothing but okay, mass into gravity. There's no temperature component, there's no pressure component. So that's why weight is not going to vary with temperature and pressure. It is not going to vary with temperature and pressure. That's why specific humidity do not vary with temperature or pressure. Do not vary with variation in temperature or pressure. Temperature or pressure. It do not vary with variation in temperature. Both relative and absolute humidity is going to vary with temperature and pressure. That's why specific humidity is constant at a given place. Generally you see specific humidity is not varying, it is constant at a given place. Fine. So what is humidity? Humidity is moisture or water vapor present in air is going to be called as what? Humidity. Which instrument is being used to measure humidity? Hygrometer. Hygrometer is being used to measure humidity. How many types of humidities are there? Yes, 3 types of humidity, which is absolute, relative and specific humidity. How do we measure absolute humidity? How do we measure absolute humidity? Weight of water vapor divided by volume. And how do we measure relative humidity? Moisture content in air divided by moisture holding capacity. And how do we measure specific humidity? Weight of water vapor divided by weight of air. Remember, absolute and relative is going to vary with what? Temperature and pressure. Specific humidity is not going to vary with temperature and pressure. Fine. So this is all about humidity component or humidity part. Next we are coming to evaporation. So next that you are finding is evaporation. What is evaporation? What is evaporation? How do you define this term? What is evaporation?
The state of changing.
State of changing. What you are changing?
One state to
From liquid to gaseous state. Yes. So evaporation is basically a change in state. Change in state. Basically, you are converting liquid into gaseous state. You are changing liquid into gaseous state. Fine. What difference lies between evaporation and boiling? What difference lies between evaporation and boiling?
Evaporation is something that we observe when it is boiled.
It is absorbed. Fine. Anyone else? Evaporation is done on
like
sun heat. Okay. Well, can't sun heat lead to boiling? You have solar cooker, no? Solar cooker and other cooker you are creating.
That will take place on the surface and
Evaporation will take place in.
boiling will take place
Hmm.
evaporation will take place above the surface.
Let's say volcanic eruption is happening in the ocean. Can it lead to boiling or not?
Boiling temperature.
Yeah, volcanic eruption is happening. Lava is coming out. Will it lead to boiling or not? No. We have discussed something called hot spring and geyser. No. What is hot spring and geyser?
The surface is heated up.
When groundwater is heated, you'll see the hot water is going to come out. That is going to be called as what? Hot spring. And when it converts into steam, then it is going to be called as what? Geyser. How it is converting into steam? How do you think it is converting steam? It is heating up, boiling is happening. That's how, okay, you see it is converting into steam. So what is the difference you are finding between evaporation and boiling? In boiling also what you are doing, you are converting the water into or liquid into what? Gaseous state. So water, when you boil water, what will happen? Water will convert into what? Liquid to gaseous state. In boiling also you are doing. In evaporation you are also seeing that it is changing from where to where? From liquid to gaseous state. So what difference you are finding between this one? So as we discussed, let's say we are taking water. Water boils at which temperature? 100 degrees Celsius. So when you are providing this much temperature, then water converts into what? Water converts into vapor state. It converts into vapor state. Fine. How much maximum temperature that has been recorded on Earth? As we discussed, it is somewhere around 58 degrees Celsius. This is something that is okay, recorded, maximum temperature recorded on the Earth. Fine. Now, at this temperature, do you think water is going to be converting into vapor state? At this temperature, do you think water is going to convert into vapor state? Yes. Why? Water is not boiling.
Not boiling.
No, it will not boil at 58 degree. No. We have discussed two concepts now, specific heat and Latent heat. What is specific heat? Temperature, amount of heat requires to raise a temperature of body by what? 1 degree Celsius. And what is latent heat?
Change the state.
Yeah, amount of heat absorbs to change the state. So let's say water is at 0 degree. Now when you are providing heat, water will heat up to how much? 100 degrees Celsius. So this is going to be which type of heat? Specific heat, which is raising the temperature of water to 100 degrees Celsius. When water will reach to this particular state, then what will happen? Then water will be changing into what? Vapor state. An amount of heat that will absorb during this period is called as what? Latent heat. So when you are heating up, it is not changing the state. First it is raising the temperature of a body. Once body temperature is raised to 100 degrees Celsius, then only what will happen? You see state is changing. That is okay, how it is happening. Clear? So when 58 degrees Celsius is there, what will happen? Water will not going to convert into vapor state. Why it is not going to convert into vapor state? Because it is not boiled to 100 degree Celsius. When it will boil to 100 degrees Celsius, then only what will happen? It can change into vapor state. That is okay there. Clear? So how evaporation is changing things into vapor state? How evaporation is changing thing into vapor state? Because you are not reaching to boiling point. Maximum temperature that you have is a 58 degrees Celsius only, and that is too high for human to survive. So that's why we discussed in the last class, whenever evaporation happens, what is going to happen? We discussed whenever evaporation is happening, you are going to feel the cooling effect. Why you are feeling the cooling effect? Like we discussed, when sweat evaporates, you feel cool down. Why you feel cools down? Because evaporation is not using the outside temperature, it is also using the inside temperature. Clear? It is not only using outside temperature, it is also going to use the inside temperature also to convert, okay, what? To convert water into vapor state. Fine. So outside temperature is how much? Let's say this is outside temperature is how much? Let's say 45 degrees Celsius. Your body temperature is how much? 37 degrees Celsius. So when you are sweating, what will happen? Evaporation is going to use internal heat also and external heat also to convert what? To convert liquid into gaseous state. So when it is you going to use internal heat, what will happen? Temperature will come down. When temperature will come down, what will happen? You will feel cooling effect. Fine. So that's why evaporation can happen at all temperature. It can happen at all temperature because it is not only using outside, but it is also using the inside heat. It is also using the inside heat to convert water into which state? To convert water into vapor state. So that's why evaporation can happen at any temperature. Clear? But as the temperature will increase, what will happen? Rate of evaporation will increase. As the temperature will increase, rate of evaporation will increase. Because 45 degree, if outside temperature is more, then what will happen? It has to use less of internal energy. If outside temperature is what? Less, then it has to use more of internal energy to convert water into what? Vapor state. So that's why rate of evaporation increases with temperature. But evaporation can happen at what? It can happen at all temperature. Fine. So evaporation is a process where change of state occurs from liquid to gaseous state, and this can happen at all temperature. Boiling only happens at which temperature? 100 degrees Celsius, but this can happen at all temperature. Why? Because it is not only using external heat, it is also using what? Internal heat. Internal heat is the reason why you feel a cooling effect. For example, how do you keep a water cool down in an earthen pot? When you are putting water in an earthen pot and etc., how the water cools down after a certain point of time? How do water cools down? When refrigerators were not there, people used to keep water where? In the earthen pot to cools down. So how it used to be cooling down? Because evaporation is happening. Evaporation is happening. And this evaporation uses water energy. Water energy, you know that water has which kind of energy? It has a latent heat. Water has which kind of energy? Specific heat. So it has some internal heat. This internal heat is being used to evaporate the things, And when internal heat is being used, what will happen? Water temperature will come down. When water temperature will come down, you'll see what? Water has cooled down. Water has cooled down. So this is what happens in case of earthen pot. When you keep something there, it cools down. Why it cools down? Because evaporation is something that is okay taking place. Fine. Any doubt regarding this particular thing? So that's why remember that evaporation and boiling are different concept. Evaporation is what? Evaporation can happen at all temperature, but as temperature will increase, what will happen? Rate of evaporation will increase. Clear?
So the evaporation is taking place in the water.
Because it is using internal energy. No? When you are using internal energy, what will happen? What will happen? This energy is being utilized. So when this energy is utilized, what will happen to temperature? Internal temperature. It will come down. So when it will come down, what will happen? Something will cool down. When temperature comes down, what will happen? Something will cool down. No? Fine. So that is what we are calling as at evaporation. Let's say sweat is there. Now sweat has to evaporate. Now sweat is using your body heat to evaporate. What will happen to heat transfer will takes place? No, when it is body heat, what will happen? Heat transfer will takes place. So body, what will happen to body temperature? When heat transfer takes place, what will happen to your body temperature? It will decrease. So that's how cooling effect is there. No. So when you sweat, why you feel a cooling effect? You feel a cooling effect because your body temperature is dropping. That is the reason why evaporation is bringing the cooling effect.
When we pour the water into the flask,
Hmm.
it remains constant.
Which flask? They're like, okay, you if you put a hot water in a glass, what will happen? After a certain point of time, what will happen? It cools down. Why it cools down?
Because of the
Because of heat transfer. Because of heat transfer. Because you see the water is having more heat. Atmospheric temperature is what? Atmospheric is having lesser heat. So heat transfer takes place from where to where? From here to here. And this heat transfer is accompanied by evaporation also. This heat transfer is accompanied by evaporation also. So this leads to cooling effect. Fine. Any doubt regarding this one? So anything cools down because heat transfer is taking place. Clear? So when heat transfer will take place, what will happen? Temperature will come down. One body temperature will come down, other body temperature will what? Go up. Clear? Heat transfer means what? Let's say one body is at 80 degrees Celsius, one body is what? 50 degrees Celsius. So what will happen? Heat transfer will take place.
but in plastic it's constant.
You have, okay, what you have a specifically flask designed, okay, for ensuring there is a warm water. Clear? So what, how do the heat transfer takes place? How do heat transfer takes place? Which process? We have discussed conduction, we have discussed convection, we have discussed radiation. These are the process how heat transfer takes place. If you minimize these process, what will happen? If no conduction happens, no convection happens, what will happen? Heat transfer will be what? Minimized. When heat transfer will be minimized, then what will happen? The things will remain warm. Clear? So flask are specifically designed to minimize what? Coating is being done specifically designed to minimize conduction process and convection process. So when it is designed, what will happen? When you keep things in a flask, okay, what will happen? It won't, okay, cool. It remains hot for a long period of time. Clear? So that is okay, what you have to keep in mind. Or you are keeping something cold, it remains cold for a long period of time because of this particular phenomenon. Clear? You minimize the conduction process or convection process over there. Fine. Any doubt regarding this one? So remember, evaporation is what? Evaporation is the change in state from liquid state to what? Gaseous state. This evaporation can take place at which temperature? It can take place at all temperature, but rate of evaporation will increase with increase in temperature. With increase in temperature, rate of evaporation will increase with increase in temperature. Fine. Now, what are the factors that are affecting the evaporation? What are the factors that are affecting the evaporation? factors that are affecting evaporation. Fine. So the first factor that will determine evaporation is amount of water available. Amount of water available. This is first factor which is determining the evaporation. Where evaporation will be more high, where more water are going to be there. Where evaporation is going to be less, where less water is going to be there. That's why evaporation, air will contain more moisture where at the oceans, and it is going to contain less moisture where on the continent. Yes. So why it is containing less moisture on the continent? Because water is less over there. Why it is containing more moisture in the ocean? Because water is more. So one factor which is impacting the evaporation is amount of water available, whether it is more or whether it is less. The second thing we have written just now is what? Temperature. As we discussed, evaporation can take place at all temperature, but rate of evaporation increases. Rate of evaporation increases with increase in temperature. Rate of evaporation increases with increase in temperature. Fine. The third thing, relative humidity. Relative humidity. This will also determine the rate of evaporation. Clear? What is relative humidity? Just now we discussed moisture contained divided by moisture holding capacity. If air is having 90% of moisture already, what will happen to evaporation? If air is already having 90% of the moisture, what will happen to evaporation? The rate of evaporation will decrease because air can't hold further moisture. Air can further only hold how much moisture? 10%. Clear? If your relative humidity is 10%, then what will happen? Air can hold more moisture. So what will happen? Rate of evaporation will what? Increase. Clear? So rate of evaporation will also vary with what? Also vary with the relative humidity. So relative humidity is less means what? Rate of evaporation will be more. Rate of evaporation will be more. And if relative humidity is less, relative humidity is high, then rate of evaporation is going to be high. So if relative humidity is less, rate of evaporation is going to be what? Going to be high. It should be low. If relative humidity is high, then rate of evaporation is going to be what? Going to be low. So as we discussed, relative humidity is low, rate of evaporation is high. If relative humidity is high, rate of evaporation will be low. So this is another factor which is impacting what? Which is impacting the evaporation. Fine. Next factor which is impacting is area of evaporating surface. Area of evaporating surface. That is okay. Another factor. Fine. What is area of evaporating surface means? What is area of evaporating surface means? Let's say you are keeping something in hot water in a big vessel. You are keeping the same hot water in a glass, in which it is going to be cools down more quickly. Larger one. Why? Why? Because area is more. Here what is happening? Area is less. So if area is less, if area of evaporating surface is less, then what will happen? You see, it will take more times to cool down, less evaporation is going to take place. If area of evaporating surface is more, then what will happen? Easier it is going to be there. Clear? So that's why area of evaporating surface also determines whether it is what? Whether more evaporation is going to take place or less evaporation is going to take place. Fine. So there are, like, you find different type of water bodies. You can have this type of water bodies also where less evaporating surface are there. You can have this type of water bodies also where more evaporation surface are something that are there. Clear? So depending upon area of evaporating surface, we'll also see rate of evaporation is going to vary. So if area is more, then rate of evaporation is more. If area is less, then rate of evaporation is less. Evaporation is less. Fine. Clear? So what are the factors we have written affecting evaporation? One is how much water is available. Second is temperature. The third is what? Relative humidity. Fourth is area of evaporating surface. This is the reason last class why we discussed at coastal areas you are going to feel what? During the daytime you are going to feel what? Uneasiness. Because in coastal areas humidity is high. Humidity is high means what? Evaporation is less. Rate of evaporation decreases the cooling effect. As a result, what we discussed, uneasy feeling will be there. And in other areas, what will happen? Since relative humidity is less, rate of evaporation is high. When rate of evaporation is high, what will happen? More cooling. More cooling means what? Less uneasiness you will feel. Fine. The next factor, which is
Then it becomes 100%, then
if air becomes saturated, then you will see the rainfall process, another process will start, fog formation, other formation. So those things, okay. So again will evaporation, that water cycle will go. Fine. So next factor is wind speed. Wind speed. If wind speed is also going to determine what? Determine the rate of evaporation. Fine. Let's say you have put cloth for drying up in the in your home and etc. and wind is blowing. And the second day when you are drying up your cloth, wind is not blowing. In which case the cloth will dry up faster? When wind is blowing. Why do you think when wind is blowing, cloth is going to dry up faster?
take the moisture from the
So yes, what you see is when air is when air is like this, static. So as we discussed, air will contain what? Contain moisture. When this moisture is filled, then what will happen to this air? When moisture is filled, it becomes saturated. What will happen to air? Air cannot absorb further moisture. So when you are putting up cloth for drying and air is not absorbing moisture, what will happen? When you are putting up cloth for drying and air is not absorbing moisture, what will happen? The cloth will take long time to what? Dry up, because the absorption is not taking place, no? Evaporation is not taking place. But if this wind which is static now moves and a new parcel of air comes, now this wind has moved over here, a new parcel of air has come which do not carry any moisture, then what will happen? You see rate of evaporation will increase, and what will happen is your cloth will dry up faster. So when wind is moving, what will happen? You see continuously new parcel of air will come. Continuously new parcel of air comes means what? You'll see evaporation rate will increase. If wind is not moving, air is static, then what will happen? The same parcel is there and it has a limited capacity to hold moisture. When it has a limited capacity to hold moisture, what will happen? Evaporation rate will decline. Clear? So that's why wind speed also determines your what? It also determines your evaporation. When wind speed is higher, evaporation is going to be higher. When wind speed is lower, what will happen to evaporation? Evaporation is lower. When wind speed is lower, then what will happen to evaporation? Evaporation is lower.
the same process
In same process in
dry
drying a cloth, yeah, same process happens. Yeah. So if wind is blowing, what will happen? Rate of evaporation will increase. When rate of evaporation will increase from cloth, what will happen? Moisture will go into what? Air. From cloth, what will happen to the moisture? It will go into the air. Which one?
the dry
Dryer. the spinner or the washing machine that you are using, that do not use this process. Washing machine uses the centrifugal and centripetal force. It is rotating, no? So you know that centrifugal force and centripetal force. When anything is rotating, what is happening? Centrifugal and centripetal force is something that is okay being applied. So whatever the moisture that is present in what? The cloth. When the cloth is rotating, what will happen? Because of centrifugal forces, the moisture will what? Moisture is going to come out and the cloth will remain as it is. Okay, so this moisture that is coming out is, we have discussed, so centrifugal force, outward forces is going to be there. So the moisture will move out as well as, okay, what? As well as cloth will move down. So that process happens in a dryer. In dryer, evaporation do not take place. Drying up, okay, means when you are putting the cloth outside. Fine, like outside for drying up, okay, when you put a cloth, there evaporation is going to take place, not in a washing machine. In washing machine, the concept is centrifugal force and centripetal force, that is going to be there. Clear? So when you are rotating, the same concept is applied when you are rotating the cloth in a washing machine. What happens is, okay, centrifugal force, this centrifugal force put the dirtiness in the cloth outside, dirt that is there in your cloth outside, and separate the dirt with the cloth because of nothing but, okay, rotation. So that process happens in case of, okay, what? In case of washing machines. Fine, any doubt regarding this particular part? So wind speed also is going to what? Wind speed also going to determine your evaporation. High wind speed means more evaporation, less wind speed means what? Lesser evaporation. Fine, that's why a combination of, if wind have this high temperature, high velocity or high speed, and less relative humidity, if any wind have this, then what will happen? If high temperature is there, high speed is also there, and less relative humidity is there, if any wind have all three, more evaporation. Yes, okay, evaporation will be much more rapid. Evaporation will be much more rapid if any wind is having these characteristics. Clear? So high temperature, high speed, and less relative humidity. Which wind has this characteristic? Which wind has this characteristic? Dry air. Anyone else? Which wind has this characteristic? Combination of all these. Chinook. Anyone else? Loo. Yes, the loo is having this characteristic. We discussed loo causes what? Heat stroke in northern India, causes the things to dry up. So loo is what? Loo is blowing when? When loo is blowing? In the March, April. It starts from March and early May. Okay, so it is blowing in summer season. Summer season means what? High temperature. Clear? Loo is blowing with a high speed. And third is what? It is a dry wind. Dry wind means what? Relative humidity is going to be what? Less. So if combination of all three is going to be there, then what will happen? Evaporation will increase. When evaporation will increase, then what will happen? You'll see heat stroke can happen, plant will dry up, soil will lose moisture, all those problems arises with the loo. So what characteristic loo have? Loo have high temperature, loo have high speed, and loo have less relative humidity. That's why we discuss loo is considered as which type of wind? It is considered as a harmful wind. Okay, we have written loo is considered as not a beneficial wind. Loo is which type of wind? Loo is harmful wind. Yeah, you have to remember. Okay, in examination, questions will come. Area in which it is blowing, direction in which it is blowing, those type of questions can come in the case. Clear? Next factor which determines evaporation is composition of water. Composition of water, that will determine. You know that water are of different type. What are different type of water? Fresh water, brackish water, saline water, or salty water. So remember that evaporation is inversely proportional to what? Evaporation is inversely proportional to salinity. Evaporation is inversely proportional to what? Salinity. If saline water is there, then less evaporation is going to be there. If fresh water is going to be there, more evaporation is going to be there. So evaporation is inversely proportional to salinity. That process you have to keep in mind. Which one? This one? as we have different type of water: fresh water, brackish water, and saline water. Fine. Evaporation is inversely proportional to be what? Inversely proportional to be salinity. If saline water is going to be there, saline water are more denser in nature. They are more denser in nature. Clear? So if saline water are going to be there, then rate evaporation will be lesser. If less denser things are there, then what will happen? Evaporation will be high. Clear? Remember the concept we have discussed. Oil is what? Oil is more denser than what? Water. So if oil is there and water is there, which will evaporate first? Water. Clear? So saline things is more denser than, that's why evaporation is what? Evaporation is going to be lesser over there. Clear? So evaporation is inversely proportional to what? Inversely proportional to salinity. Clear? Evaporation is inversely proportional to salinity. For example, you in, like, if you see your kitchen sink if you see, and you have put water, after 1 hour, what will happen in the kitchen sink? That water will evaporate. You'll see the kitchen sink has become dried up. Fine. But if you are washing something which contain oily, if you are washing any utensils which contain oils, and this oil is now spread in kitchen sink, what will happen? Oil will be remain. Okay, if you touch this thing, oil will remain after 1 hour, 2 hours also. You have to, okay, rub it and remove the oil. Okay, why? Because oil is not evaporating. Denser things are there. Clear? So when denser is going to be there, then what will happen? Evaporation is going to be lesser. So evaporation is inversely proportional to what? Salinity. So in saline water, what will happen? Rate of evaporation will be less. In fresh water, what will happen? Rate of evaporation will be what? Higher. Clear? So that is what concept you have to keep in mind with regard to composition of water. Fine. Now let's say a question comes like this. Which statement is correct? Both are correct. Yes, both are correct. Clear? So rate of evaporation, as we discussed, is inversely proportional to what? Salinity. So when rate of evaporation is inversely proportional to salinity, river contain which type of water? Fresh water. So rate of evaporation will be higher at here. Oceans contain which type of water? Saline water. But since since ocean is much bigger in nature, even if a small rate of evaporation is there, air will still have what? Air will still have a more moisture, because ocean contains more amount of water, while the river contain only a small amount of water. Okay, river contains only a small amount of water. That's why even if higher rate of evaporation are there, then also what will happen? Air will contain lesser moisture over here. Air will contain more moisture over here. Clear? So that's why moisture content in air will be more over ocean than at river. So don't get confused between this point. Don't get confused between first point. First point is saying what? Amount of water available. If water available is more, then moisture content is going to be more. If amount of water available is less, moisture content is going to be less. But rate of evaporation is what? Rate of evaporation depends upon what? Depends upon salinity. It depends upon salinity. So higher rate of evaporation is going to happen where? At the rivers, at the fresh water, and lower rate of evaporation will happen at the oceans. Fine. Any doubt regarding this particular thing? So this is the point you have to keep in mind. That's why both statements are something that are correct statement. Fine. Next factor that affects the evaporation is air pressure. Now, if air pressure is low at the surface of liquid, air pressure is low at surface of liquid, then what will happen? Higher rate of evaporation. Higher rate of evaporation. and if air pressure is more at surface of liquid, then what will happen? Lower rate of evaporation. Lower rate of evaporation. Fine. So this differences you have to keep in mind with regard to air pressure. Air pressure, if it is more, then what will happen? Higher. The air pressure, if it is clear. So air pressure, if it is low, then you have high rate of evaporation. Air pressure, if it is more, then you have what? Low rate of evaporation. Why this happens? Why this happens? Why this happens? Anything heated, which type of temperature is going to be there? Anything is heating, then which type of temperature, which type of pressure is going to be there? Low pressure. Low pressure means what? If heating is more, then what will happen? Higher rate of evaporation. If heating is less, then what will happen? High pressure. If heating is less than high pressure means what? Substance is cool more. When substance is cool more, what will happen? Lower rate of evaporation is going to be there. Clear? Any doubt regarding this one? So anything when you are heating, what will happen? Low pressure is going to be formed. Low pressure means what? Higher rate of evaporation. Anything when you are cooling down, high pressure is going to be formed. High pressure means what? Lower rate of evaporation is going to be there. So air pressure also determines that whether evaporation is going to be higher or evaporation is going to be lower. Last thing that you find is what? Last thing that you find is transpiration. Transpiration. What is transpiration? When plant loses water. When plant loses water, then this process is called as what? This process is called as a transpiration. Clear? Fine. When plant loses water, then you will find what? It is called as a transpiration. So where you'll see more amount of water vapor or more amount of evaporation? In the case of forest. Why more forest? More forest means what? More transpiration by the plants. Less forest means what? Less transpiration by the plant. So that's why you'll see evaporation also varies with what? Also varies with the number of plants. That's why we are saying that with the expansion of urban areas, what we are doing? We are cutting the trees. When we are cutting the trees, what will happen? Less amount of what? Evaporation. When less amount of evaporation, what will happen to rainfall? Less rainfall. So that's why you see the climate of Bangalore is changing. Why climate of Bangalore is changing? Earlier more rainfall used to happen, and now what is happening? Lesser rainfall is happening. Why lesser rainfall? As and when expansion is going to happen, what you see? Cutting of trees. Cutting of trees means what? Less transpiration. Less transpiration means what? Less condensation, less cloud formation, less rainfall is going to be there. Clear? So that is the reason with lakes. Earlier you had more amount of lakes in Bangalore. Now what will happen? You're filling the lakes, creating what? Creating the buildings over there and other things you are using for real estate purposes. So evaporation is now getting more and more more and more lesser in case of Bangalore, and that's why weather is something that is changing. Fine. So this is what you are seeing. So these are the factors that are determining what? These are the factors that are determining your evaporations. Fine. So you have a water cycle. What is a water cycle? So first what will happen? Evaporation will happen. Then what will happen? Cooling and condensation happens. Cooling and condensation happens. And after cooling and condensation, what will happen? Precipitation happens. Precipitation happens. Rainfall happens. Then again, what will happen? Evaporation, cooling, condensation, precipitations. This process continues, and this is what we call as a water cycle. This is what we call as a water cycle. So now we are done with what? We are done with this part. Evaporation part, humidity, evaporation. What are the factors affecting evaporation? We are done with this part. Now, secondly, we are coming to which part? Condensation part. Cooling and condensation. How it is happening? Fine. So generally, you have two processes of cooling, which we have discussed earlier. Two processes of cooling happening. One is adiabatic cooling and another is a non-adiabatic cooling. Non-adiabatic cooling. Now, how non-adiabatic cooling takes place through this process, as we discussed, convection, conduction, and radiations. These are the process of non-adiabatic cooling. Non-adiabatic cooling and adiabatic cooling. There are two types of cooling and condensation happens. Fine. So what is adiabatic cooling? Anyone? What is non-adiabatic cooling? Earlier we discussed adiabatic lapse rate and non-adiabatic lapse rate. So what is adiabatic cooling? Non-rising is the non-adiabatic, and rising means what? Adiabatic. Any other difference we have discussed? Height increases and temperature also will. Temperature will decrease. No, as you go up, temperature will decrease. Adiabatic lapse rate. Lapse rate means what? As you are going up, what will happen? Temperature should decrease. Okay, that is what lapse rate. So in diadiabatic also, what will happen? As you go up, temperature will decrease. That's why we have written 9.8 degrees Celsius per kilometer. Temperature decreases how much? 9.8 degrees Celsius per kilometer. So it decreases happening. Clear? What is adiabatic? Remember, we discussed when there is what? When there is an exchange of heat. When there is an exchange of heat happening between whom? System and surrounding. When there is an exchange of heat happening between whom? System and surrounding. Such type of cooling is called as what? Cooling is called as a non-adiabatic cooling. When there is no exchange of heat, when there is no exchange of heat, when there is no exchange of heat happening between system and surrounding, when there is no exchange of heat is happening, such type of cooling is called as what? Such type of cooling is called as a adiabatic cooling. Clear? So if you remember lapse rate concept, we discussed non-rising air are there. This is non-rising air. And we discussed there is there is a rising parcel of air. There is a rising parcel of air. So when there is no exchange of heat between these two, that is system and surrounding, that is rising parcel of air and non-rising parcel of air, when there is no exchange of heat is going to happen, such type of cooling are called as what? Such type of cooling are called as a adiabatic cooling. Such type of cooling is called as what? Adiabatic cooling. When no exchange of heat is happening between system and surrounding, such type of cooling is called as what? Adiabatic cooling. When exchange of heat is happening between system and surrounding, then it is going to be called as what? Non-adiabatic cooling. Fine. So as we discussed, when air is rising, what is happening? As air is rising, what is happening? Pressure is declining. As you go up, what will happen to the pressure? As you go up, what will happen to the pressure? Pressure will decline. When pressure will decline, what will happen? Temperature. Temperature also declines. When temperature declines, what will happen to volume? When pressure declines, what will happen to temperature? Temperature will decline. When temperature will decline, what will happen? We say that the gas is cooling. Why gas is cooling? This is what we are saying. Okay, as the air is going up, what is happening to pressure? What is happening to pressure? Declines. Why pressure declines? No, temperature declines because pressure is declining. Why pressure is declining? We discussed air is densest at where? At the surface. As you go up, air what? Air is becoming less dense. Why? Because of gravity. We discussed all the heavier gases are attracted by what? By the earth. So that's why your all heavier gases are where? At the earth. As you go up, you feel a problem in breathing. No? Why you feel a problem in breathing in mountain areas? Less air is present. Less air means what? Air is not dense. Air is more dense where? At the surface. As you go up, air is going to be what? Less dense. When air is going to be less dense, what will happen? Pressure will be less. Because what will happen? What is pressure means? More air means what? More air weight. We discussed why pressure we are feeling. Why pressure we are feeling? This pressure is nothing but weight of whom? Weight of the gases or weight of the air. Clear? So more gases are going to be present means what? More weight we are going to feel, more pressure we are going to feel. As we are going up, what is happening? Less gases are present, less weight we are going to feel. Fine. So what you see is as you are going up, what is happening? Pressure is declining. Why pressure is declining? Because less gases are present. So as pressure is declining, what will happen to temperature? temperature will decline, because we have discussed what? We have discussed this equation, if you remember, PV is equals to what? nRT, ideal gas equation. We discussed pressure and temperature are what? They are directly proportional. Their pressure and temperatures are what? Directly proportional. So when pressure will decline, what will happen? Temperature will decline. And when temperature will decline, what will happen? Gas will cool down. So this type of cooling is called as what? This type of cooling is called as a adiabatic cooling. Clear? This type of cooling is called as which type of cooling? Adiabatic cooling. Why the temperature here is declining? Why temperature of this gas is declining? Temperature of this gas is declining because as it is rising up, pressure is declining. So that's why its temperature is also declining. There's no exchange of heat happening over here. There's no exchange of heat happening over here. So that's why this type of cooling is called as which cooling? Adiabatic cooling. While when there is exchange of heat happens, then what will happen? It is going to be called as what? Non-adiabatic cooling. Clear? So that is what we have discussed with regard to adiabatic lapse rate and normal lapse rate. That's why we discussed adiabatic lapse rate happens in a rising air, because here air is rising and pressure is declining. That's why air is cooling up. Lapse rate is happening. Clear? Non-rising air, you will see which type of lapse rate? Normal lapse rate, that is non-adiabatic cooling. Fine. Any doubt regarding this particular part? So remember that there are two ways in which air can cool down. There are two ways in which air can cool down. What are the two ways? What are the two ways in which air can cool down? Either adiabatic cooling or non-adiabatic cooling. What is adiabatic cooling? When there is an exchange of heat happening between system and surrounding, then it is going to be called as a non-adiabatic cooling. When there is no exchange of heat happens between system and surrounding, then it is going to be called as what? Adiabatic cooling. Fine. Fine. So these are okay. What? These are important points that you have to keep in mind. Air can cool either adiabatically, or air can cool either non-adiabatically. Fine. Now, next thing, air can cool either above freezing point or below freezing point. Air can cool either above freezing point or air can cool either below freezing point. Fine. Which one? No, it is not related with adiabatic cooling. As we discussed, cooling here is adiabatic cooling means what? No exchange of heat happens. So now this cooling can happen either above freezing point or this cooling can happen either below freezing point. Above freezing point means what? Above freezing point means what? 0 degrees Celsius. Below freezing point means what? Less than 0 degrees Celsius. So either cooling can happen above 0 degree or cooling can happen below 0 degree. Clear? So this is what we call as a air cooling above freezing point or air cooling below freezing point. Fine. So if it is cooling above freezing point, what will happen? The vapor is going to convert into what? Vapor is going to convert into water. And if it is cooling below freezing point, then what will happen? Vapor will convert into ice. Yes. Vapor will convert into ice. So that's why cooling can happen either above freezing point or cooling can happen either below freezing point. You can see vapor converting into water or vapor converting into ice form. Fine. What is a process in which solid is directly converting into gaseous substances? So normally you convert solid into liquid, liquid into gas. But what if gas directly convert into solid and solid convert into gas? What this process is referred as? Any idea? If you convert, normally you convert solid into what? Liquid, liquid into what? Gas. Clear? Ice you convert into water, water converts into what? Vapor. Clear? If you convert ice directly into the gas, then this process is going to be referred as which process? This process is referred as a sublimation. This process is referred as what? Sublimation. When solid is directly converting into what? Gaseous. This is considered as a sublimation. So when gas is directly converting into solid, it is referred as a desublimation. It is referred as a desublimation process. Fine. Fine. So when vapor is converting into water, this is called as what? This is called as a condensation. But when vapor is converting directly into ice, it is going to be called as what? Desublimation. When vapor is converting into ice, it is going to be called as what? Desublimation process. Fine.
Is there any other name for this?
Which one?
For the sublimation?
No, it is known as a sublimation.
We tried this in chemistry.
Yeah, in chemistry only you will find sublimation. Huh? That is where you will find sublimation process. Fine. So remember that when evaporation happens, after evaporation, which process is going to come? Cooling and condensation process. Air can cool either adiabatically or air can cool either non-adiabatically. When cooling adiabatically, no exchange of heat will happen between system and surrounding. When cooling non-adiabatically, what will happen? You'll see convection, conduction, radiation, all these processes are going to occurring. Clear? And there will be exchange of heat between system and surrounding in a non-adiabatic cooling. Clear? So cooling can happen either above freezing point or cooling can happen either below freezing point. If it is happening above freezing point, vapor will convert into water and this process is referred as a condensation process. If it is happening below freezing point, then vapor will directly convert into ice and this process is referred as what? Desublimation process. Fine. Next, another fine. So these are okay. What? These are different things that are going to occur when condensation will happen. Either dew can form, fog can form, white frost can form, mist can form, smoke can form, cloud can form. These are okay. What? These are the different terms that you have to keep in mind which can form due to condensation. There is also a term which is referred as a haze. Haze doesn't occur due to condensation, but you can use it. It is a dry air. Haze is dry air. There is no condensation as such in case of haze. But related to smog and the fog, you will have certain differences. That's why you also have this haze concept. Clear? So what is dew? What is dew? So dew is when you see what? When you see any surface which is sufficiently cools down. Any surface which is sufficiently cools down means it is much colder and air comes in contact with this colder surface. Air containing moisture comes in contact with the colder surface. That is when you are going to encounter the dew. Clear? So if any surface is there which is sufficiently cools down, it is a colder surface and air, it comes in contact with what? Air comes in contact with this colder surface. So what will happen to air? It will also cools down. So what will happen to the moisture in the air? That will also cools down. That's when you're gonna find dew. So dew are the water droplets. These are the water droplets appears onto the surface. When moist air cools down after coming in contact with colder surface. Above colder surface above freezing point. So here the condensation will take place above what? Condensation will take place above freezing point. Fine. So water droplets appears onto the surface when moist air cools down after coming in contact with colder surface, ever freezing point. Clear? So ever freezing point means vapor will convert into what? Vapor will convert into water. So condensation is taking place ever freezing point. Fine. If condensation takes place below freezing point, then what is going to be formed? Then it is going to form a white frost. The same thing. So when air comes in contact, when moist air comes in contact after coming with a colder surface, but condensation here takes place below freezing point, then it is going to form what? Then it is going to form a white frost. Clear? So only difference between dew and white frost is what? Dew is, in dew condensation is taking place above freezing point. In white frost what is happening? Condensation is taking place below freezing point. Fine. So here what is going to be formed? The vapor is directly converted into what? Ice or snow. So vapor is directly converting into ice or snow because condensation is taking place below freezing point. Clear? So those differences you have to keep in mind when water droplets appear onto the surface and when moist air cools down after coming in contact with a colder surface, then condensation takes place above freezing point, then it is dew. If condensation takes place below freezing point and vapor convert into ice or snow, then it is going to be called as what? Frost, white frost. Fine. What are the conditions? What are the conditions? So as we discussed, one thing is required, colder surface are required. So when you see colder surface, either you need to have which type of night? Long night you need to have, or you have to have which type of night? Winter night. So either you need to have a long night or you have to have winter night. Then you will see the surface becomes colder in nature. So one of the condition for dew and frost to occur is what? One of the condition for dew and frost to occur is you require long night and you require which type of night? Winter night. Clear? Now, as we discussed, when the earth cools down, you need to have which type of sky? Clear sky and stable weather. Why clear sky and stable weather? Because if last class we discussed, if clouds are there, then what will happen? They will reflect the heat. So earth will not cool down. So long night, for having colder surface, you require clear sky, you require stable weather to happen. Fine. Fourth thing, what is again required? Calm air is required. Why calm air? Because we discussed, if air is moving, then what will happen? Then when air is moving, what will happen? It will not be in contact with the colder surface. When it will not be in contact with the colder surface for a long period of time, what will happen? Cooling will not happen. Air will move away. Clear? So for air to cool down, what will happen? This contact need to be there for a longer period of time. When this contact is going to be there for a longer period of time? When air is what? Air is static and not moving with a high speed. Clear? So calm air conditions are going to be required for which to occur? For dew to occur. So when dew is going to be formed, or when frost is going to be formed? When there is what? Long night. When there is what? Winter night. When there is a clear sky and stable weather. And next is calm air. And if these conditions are there and condensation takes place above freezing point, then dew. If these conditions are there and condensation takes place below freezing point, then it is going to be called as what? Frost. Fine. Any doubt regarding this one? Now again, you just keep in mind this particular part, that what is the criteria for temperature inversion? What are the conditions we have written down for temperature inversion? Yeah, calm and stable weather, then long night, winter night, and what is other thing? Calm air. So same conditions, what is there for temperature inversion? Same condition you are seeing for formation of dew and frost. Clear? So dew and frost is having the same condition when you see temperature inversion phenomena. Fine. So condition you have to keep in mind for dew, same condition for frost, same condition for temperature inversion. Clear? Like what you see is okay, polar regions have what? 6 months of days and 6 months of night, no? So they have these particular conditions. Sometimes long night may also long night may also occur in temperate region. Clear? In temperate region, what is happening? Let's say summer times are there. Clear? Summer duration of length day will increase, but what will happen? You might see night time is still longer than what? Daytime. Clear? When sun is when sun is here, Tropic of Cancer, at this region you might see increase in what? Daytime, but still what will happen? Night may be nothing but longer in this particular region. Fine. If sun is over here, you'll see further lesser time, but night is for night can be still still nothing but longer in this region. Clear? So that's why we are writing either long night or we are writing either winter night. Fine. So this is basically the figure of whom? This is basically the figure of white frost. So you can see white frost condition when everything is covered in what? Covered in snow. So this is condition of white frost, and dew is what? Sometimes you see water appearing on what? Grass. Okay, morning when you are waking up, you find water on grass, or you might see water on leaves. That is there. Sometimes you see glass panels on your windows and etc. You see what? If it is made up of glass, sometimes you see water coming on the water coming on those glass. So this glass is acting as what? Colder surface, or your leaves is acting as a colder surface, or you see what? The grass is acting as a colder surface on which condensation is something that is happening. So that is a difference that lies between what? That is a difference that lies between dew and frost. Fine. So what is a condition for dew? What is the condition for dew? Long night. Second thing, long night, calm air. Then stable weather, clear sky. If condensation takes place above freezing point, then dew. If condensation takes place below freezing point, then frost. Fine. Have a break and then we'll cover other things. Yeah, ice only. Frost means why we call it as a thin ice, thin snowfall happening and covers the entire surface. That is what we call as a white frost. Fine. So see, it is not a rainfall. It is not a rainfall that snow is coming down. What is happening is the tree are providing what? Colder surface. As a result, the moisture that is present in what? Moisture that is present in air is condensing. Like you see, dew is formed over what? Grass. Like that, seeing or dew is formed over leaf. Like that, what will happen? Ice is or snow is depositing over what? So you can see here what is happening. This part you don't see what? Covered with ice, but you see leaves and etc. are something that are covered with what? Ice. Ground where moistures are, you can see this ground can act as a colder surface. So here you see what? Here you see formation of white frost. So it's not like a rainfall, that snow rainfall is something that is happening. Rainfall is different, snowy rainfall is different. Here what we are seeing is what? The condensation is happening because of what? Colder surface. What is colder surface? We discussed glass can act as a colder surface, leaf can act as a colder surface, grasses can act as a colder surface, tree can act as a colder surface. Only thing is that it need to be sufficiently cools down. If it cools down below freezing point, then what will happen? The moisture that is present in air will directly convert into what? That is directly going to convert in a ice form or snow form. Fine?
So this is the reason why the country like some other countries for few months the entire ground water
Yeah, ice. Yeah, that is the reason. Some, if you have seen any movies and Hollywood movies and etc., sometimes on the car on the surface of car, you'll see, okay, on the car and etc. Someone is coming on winter on car, what is depositing? Ice and other things are depositing. Why that is happening? Why that is happening? Because a car is acting as what? Cooling surface. Okay, so that's why you see deposition of what? Deposition of ice on the car, that is okay there, or frost. Okay, it is nothing but white frost only which is deposited on the car. Fine, that is okay there. Which one? Cloud means rainfall is happening. When it is coming from cloud, it will be rainfall. When it is coming from the air directly condensing into what? Air directly condensing into vapor, then it is going to be called as what? Dew or white frost. Clear? So this is a colder surface, this is the air. As we discuss, anything you keep in contact with a colder surface, what will happen? It will cool down. So air is in contact with a colder surface, so what will happen? Air will cool down. So what will happen to moisture that is in the air? It will cool down. If this condensation is happening above freezing point, then dew will form. If this condensation is happening below freezing point, then what will happen? Frost will form. We have still not discussed concept of cloud. How cloud is formed, how rainfall is happening, we are not going to that. So it's not a snowy rainfall, it's just conversion of whatever moisture that is present onto the earth surface into what? Into dew form or frost form when they encounter a colder surface. Fine? Any doubt regarding this? Thank you. So have a break, then we'll just So now we are clear with the two terms. One is called as dew, another is called as a white frost. The next terms are fog and smog or mist. So there are two terms. One is called as a fog, another is called as a mist. Now, how these are different from the dew or white frost? We discussed for dew and white frost, we require which type of surface? A colder surface. So here the condensation is happening when air is coming in contact with the colder surface. But what if the air doesn't require any colder surface and the vapor that is present condenses in the air itself? Vapor condenses in air itself. Clear? So it doesn't require a colder surface like we discussed. It doesn't require like this. Rather than when vapor start condensing in the air itself, then what is going to be formed? Fog and mist are going to be formed. So when you don't have any colder surface, rather air itself, vapor present in the air itself starts to condense in the air itself, then it is called as what? It is called as a fog or a mist. Fine. Again, what is being used here as a surface? Because we are not having any glass, we are not having any grasses, leaves, trees, buildings which are acting as what? Acting as a colder surface here. So what acts as a colder surface here? On what surface condensation happens? Because you have lot amount of what present? You have lot amount of what present? Dust particles that are present in the air. Clear? So when condensation happens around these particles, these particles act as what? This particle act as a surface. This particle act as a surface, and when condensation happens around these particles in the air, then it is going to be called as what? It is going to be called as a fog or a mist. Clear? Any doubt regarding this one? So when air condenses, when very wide air, when air condenses in air itself, then it is going to be called as what? It is going to be called as a fog or a mist. Fine. Any doubt regarding this one? Now, there's a slight difference between fog and slight difference between mist. What is the difference? The fog generally have less amount of moisture. They have less amount of moisture, or here you will see water droplets are less. After condensation, what you find is water droplets are less. Here in mist, what you're going to find? You're going to find more amount of moisture, and water droplets are more. Water droplets are more. So mist have more moisture than what? Mist have more moisture than the fog. That you have to keep in mind. Second, here water droplets that is formed are small in nature. They are small in nature, and that's why it is less dense. It is less dense. Here water droplets could be heavy. Water droplets that are formed is heavy. That's why it is more dense. It is more dense. So here what is happening? Water droplets are less dense. Here what you are seeing is water droplets are more dense. Fine. And what you find is here, because water droplets are less dense, visibility is more. Visibility is more. And here what is happening? Visibility is less. Visibility is less. So this is difference lies between fog and a mist. In both fog and a mist, what will happen? The water vapor will convert into what? Water vapor will convert into water. This will happen in the air itself. No colder surface as such required, because dust particle act as what? Dust particle in the air itself act as a cooling surface. So here in fog, what will happen? You will have lesser moisture. Here you will have more moisture. Here what will happen? Water droplets that are formed are more heavy, more dense. Here water droplets that are going to be formed are small and less dense in nature. So that's why, since water droplets are less dense in nature, visibility here is more. Here visibility is less in nature. Clear? So when fog is formed, you see visibility is what? Visibility decreases. So why visibility decreases? Because fog, the water droplets are very dense in nature. Fine. So that difference lies between what? That difference lies between fog and a mist. Fine. So what is the difference between what? What is the difference between the dew, frost and fog mist? What is the difference? In dew frost, what you require? You require a colder surface. In case of fog and mist, the condensation happens in the air itself. And what acts as a cooling surface? Dust particles and other particles that are present is acting as a cooling surface. Clear? Condensation will happen below freezing point, or condensation will happen above freezing point? Condensation is going, it is going to be above freezing point, because what is formed? We discussed water droplets are being formed. So condensation is going to be above freezing point in case of fog and a mist. Condensation is going to be above freezing point in case of fog and a mist. Fine. Any doubt? So this is a foggy condition that you are seeing. When you see more moistures are something that are present in what? More moistures are something that are present in the air itself. And what you see is, okay, as we discussed, frost means the ice will form, and dew means what? Surface will act as a dew. This is a case of smog. Clear? This is a case of smog. Smog means what? We are mixing smoke and fog together. When we are mixing smoke and fog together, you can see in smog further less visibility. Here you are seeing more visibility. Here you are seeing further less visibility. That is okay there. Clear? So what happens in a smog is when smoke and fog mix together. So when you have smoke and fog mixing together, it is going to form what? It's going to form smoke. It is going to form smoke. Clear? Now there is also a term we have written, haze. What is haze? Now when too much amount of dust particles are there in the air, what will happen? It is a dry air, do not contains any moisture. It is a dry air, do not contains any moisture, but a lot of dust particles are there. When a lot of dust particles are there, what will happen? What will happen? Do you have more visibility or do you have less visibility? Less visibility. Clear? So in haze also you'll see less visibility. But it is different from fog and mist, because in fog and mist visibility is lesser because of what? Because of denser water droplets that are going to be formed. But here visibility is less because of presence of huge amount of dust particle, dry air is going to be there. So that happens in case of haze. So haze also have a less visibility, but it is in because of dry air, and dry air contain lot amount of what? Dust particles. Fine. So now the next thing is a smog. So as we discussed, the term smog stands from what? Smoke plus fog, and it affects your visibility. It affects your visibility. Visibility becomes further lesser in smog. Fine. The two terms which you have to keep in mind is primary pollutant and secondary pollutant. So the two terms that you have to keep in mind is primary pollutant as well as secondary pollutant. Clear? So pollutant are of two kinds that you will read in environment. Just for understanding, I'm telling you this two concept. One is called as a primary pollutant and another is called as a secondary pollutant. What is primary pollutant? These are those kind of pollutant. These are those kind of pollutant which exist in environment, in same form, in which they are emitted, or released. Those type of pollutant are referred as what? Those type of pollutant are referred as a primary pollutant. Clear? What is a secondary pollutant? These exist in different form. These exist in different forms from which they are emitted or released. Clear? So when any pollutant is released in the environment and it exists in the same form, then it is going to be called as what? It is going to be called as a primary pollutant. When pollutant are released and it reacts with other substance, exist in different form, then it is going to be called as what? Secondary pollutant. So those are okay main difference that you find between primary pollutant as well as secondary pollutant. Fine. For example, we have discussed something about what? Something about acid rain. What is acid rain? Yeah, we discussed sulfur dioxide, which is emitted. Sulfur dioxide, which is emitted when react with the water, it forms what? Sulfuric acid. So it is going to be which type of pollutant? Secondary pollutant, because it is formed due to what? It is formed due to some reaction. It is not emitted in this form. Sulfuric acid is not emitted in this form. It is formed due to reaction. So this is going to be which type of pollutant? It is going to be secondary pollutant. That is okay there. Clear? Any doubt regarding this particular part? So those pollutants which exist in the same form, in which they are released. For example, plastics. When you are releasing plastic, what is happening? What will happen to the plastic? Degradation does not happen. It exists in the same form. That is okay there. Clear? So what you see is those type of pollutant which exist in the same form in which they are released into environment, that are called as a primary pollutant. Those that exist in different form is going to be called as what? Secondary pollutant. Clear? So because of this, there are different kind of what? Different kind of smog. One is called as a London smog or sulfurous smog. And second type of smog is called as a Los Angeles smog, also known as a photochemical smog. Fine. So London smog or sulfurous smog, also second is called as a Los Angeles smog or photochemical smog. Fine. Any doubt regarding this particular part? So what is London smog or sulfurous smog? What is London smog or sulfurous smog? As the name indicates, what is being released? It is being released it is formed due to release of sulfur dioxide. That's why it is referred as a sulfurous smog. And since it was first observed in the London, that's why it is called as what? London smog. Clear? So this smog, sulfurous smog, is formed due to what? Release of sulfur dioxide. And since it was first observed in London, that's why it is called as a London smog or sulfurous smog. Fine. The second type of smog is called as a Los Angeles smog or a photochemical smog. This is a second kind of smog. Now this was first observed where? In the Los Angeles, and this was generally observed in the summer month due to release of high amount of nitrogen oxide. That's why it is referred as a photochemical. Photo means what? Light. So light is something that is okay required to form this type of smog. That's why it is referred as what? It is referred as a photochemical smog or summer smog sometimes. This London smog is also referred as a winter smog because it is generally observed in winter. So that's why it is observed. It is written as a winter smog. Clear? Fine. So what is smog? We discussed smog is smoke plus fog. When they mix together, visibility reduces, and this is called as smog. There are two types of smog that you find: London smog and Los Angeles smog. One is known as winter or sulfur smog, another is known as a summer or a photochemical smog. Fine. So what happens in a London smog? Now, what happens is, after industrial revolution, you know that after industrial revolution started where? Started in the Britain. Industrial revolution started where? Started in case of Britain. There you see industrial revolution. And when it started in the Britain, what had happened? You are using now machineries. To power the machineries, what is required? Electricity, energy are required. To power this machinery, what is required? Electricity or energy is required. How you are producing this electricity or energy? Through thermal power plants. How you are producing this electricity or energy? Through thermal power plant. Thermal power plant means what? Coal. You are using burning of coal is being done. So coal, if you remember, we discussed that best form of coal is which type of coal? Anthracite coal. And if you remember, we discussed bituminous type of coal also, lignite type of coal also. We discussed coal exists in various forms. Clear? Now, we discussed anthracite is the best form of coal, contain around 90% of carbon. But what is 10%? What is 10%? If 90% is carbon, what is 10%? These are referred as impurities. These are referred as what? Impurities. Impurities means these are other substances. There are other substances that are present. One is sulfur. One is sulfur is present. Another is what? Another is nothing but, okay, small traces of water is present. Clear? So a lot of other things are something that are also present in the anthracite type of coal that is okay there. That's why when you burn coal, what is happening? Some amount of ashes are there, some amount of other things are left. Why it is left? Because coal does not burn properly, completely, because there are other impurities that are present. Clear? So when you burn sulfur, when you are burning coal, you are burning sulfur. When you are burning sulfur, what is being released? Sulfur dioxide is something that is okay being released. Clear? So that's why this phenomenon was first observed in London, because in London you see the industrial revolution started. In London you switch to thermal power plant, burning of coal. You saw the release of whom? You saw the release of this one, and sulfur dioxide is being released due to burning of coal. Clear? Now what happens is, okay, what happens is, during winter, what will happen? We discuss earth becomes too cold. When earth becomes too cold, what will happen to air? What will happen to air? It also cools down. But what will happen to upper air? What will happen to upper air? Since it is not in contact with what? Since it's not in contact with the earth's surface, it will remain warm. And this phenomena is referred as what? This phenomena is referred as what? Temperature inversion. This phenomena is referred as what? Temperature inversion. As you are going up, temperature is increasing. So this phenomena is referred as what? This phenomena is referred as a temperature inversion. Clear? So when winter seasons are there, when winter conditions are there, you are seeing phenomena of which type of thing? Temperature inversion. Now, whatever burning, whatever burning material is there, that is going where? That is going into atmosphere, that is going to air. So sulfur dioxide is going where? Sulfur dioxide is going into the air, because you are burning at the ground. Clear? But this air will not rise up. Why? This air is not rising up. Why it will not rise up?
Because it is dense.
Yeah, cooler air is going to be more denser than the warmer air. So this air will not rise up. When this air is not rise up, what will happen? All the sulfur dioxide or pollutant which are being released are close to what? Are close to the surface. Okay, and they are going to be inhaled by whom? They are going to be inhaled by the people. So people will inhale these, because these pollutants are present in the air. You are inhaling these pollutants. Why this pollutant is not going up? Because of temperature inversion, this layer becomes more colder. So that's why air will not rise up. It will remain at the ground, and people will start inhaling the sulfur dioxide. Now when sulfur dioxide people will inhale, what will happen? What will happen? It's bind with whom? It bind with your hemoglobin. It bind with your hemoglobin. Clear? What is the role of hemoglobin? What is the role of hemoglobin? It binds with oxygen, and oxygen is supplied to what? Oxygen is supplied to all the cells. So RBCs contains what? Hemoglobin. Hemoglobin binds with oxygen, and RBC supplies this oxygen to all the cells. So if sulfur dioxide binds with this, then what will happen? Oxygen will not be supplied to the cell. If oxygen will not be supplied to the cell, what will happen? People will die off. Clear? So this has led to lot of death. This has led to lot of death. So that's why it is called as what? It is called as a London smog. That's why this is called as what? London smog. Occurs when? In winter. Why winter? Because in winter you will see what? Winter you will see the colder, all these sulfur dioxide will be trapped. If summer is there, then what will happen? When summer is there, what will happen? Earth will get heated. When earth will get heated, what will happen to air? It will also get heated, so it will rise up. So in summer, this sulfur dioxide is going to go up, but in winter it is not going to go up. It will remain trapped closer to what? Closer to the surface. When it remains trapped closer to the surface, what will happen? People will nothing but inhale it, and when people will inhale it, what will happen? Problem will be created, death will be created. Such type of smog are referred as a London smog or winter smog or sulfurous smog. Clear? That's why when you see any asthma patients are there or other patients are there, doctor doesn't advise them to go for a morning walk. Why? Asthmatic patient are not advised. Why colder? Because if morning walk you are going after night. If night are too cold, then what will happen? Air becomes too cold. All pollutant are going to be what? Trapped near the Earth's surface. When trapped near the Earth's surface, what will happen? You are going to inhale more pollutant. When you are going for a walk, you are going to inhale more amount of nothing but pollutant, and more pollutant. Already you have a breathing problem, asthma already you are having. Again, more pollutant when you are inhaling, it will aggravate the situation. That's why doctor don't advise them, especially in northern part where winter conditions are more. In southern India, you don't have that much condition, but in northern part where more conditions are there, you'll see nothing but doctor advise asthmatic patient not to go for morning walk and other walk. Fine. Yeah, for normal people also it is not safe. But especially it is what it is especially it is unsafe because already you have aggravating conditions. So especially it is unsafe for whom asthmatic patient and etc. They should not venture out. Fine. So this is what this is the problem happens, and why this happens? Because of temperature inversion phenomena. This happens because of temperature inversion phenomena. Clear? Now the second type of smog that we have written is what? Los Angeles or photochemical smog. So you have Los Angeles smog or photochemical smog. That is the second type of smog you are having. Fine. Now this occurs due to high amount of nitrogen oxide releases. This occurs due to high amount of what releases? Nitrogen oxide. That London smog is occurring due to sulfur dioxide release. This occurs due to more release of nitrogen oxide. From where the nitrogen oxide will be released? More release from vehicular emission, from vehicles. When you are burning petrol, diesel, vehicular emissions. Some also releases from thermal power plant. If impurities are present in coal, some also releases from nothing but thermal power plant, but mostly coming from where? Mostly coming from vehicular sources, vehicular emission. That is one powerful source of nitrogen oxide. Fine. Now this NOx breaks down in the presence of whom? In the presence of light. This NOx breaks down into presence of light, forming NO plus O. Let's say it is NO2. So this NO2 breaks down in the presence of light into NO plus O. Clear? This O reacts with whom? Oxygen, forming what? O3, which is ozone. And if you remember our ozone discussion, we discussed surface ozone is what? Surface ozone is toxic, but stratospheric ozone is what? Beneficial, because stratospheric ozone help us in what? Help us in, yes, from UV rays. It helps us in protecting from UV rays. So that's why the stratospheric ozone is beneficial, but at the ozone that is formed at the surface is problematic. So where the vehicular emissions are there? Vehicular emissions are there at the surface. Vehicular emissions are going to be there at the surface. And you know that O3 is going to be which type of gas? Is it heavier gas or lighter gas? O3 is which type of gas? Heavier gas or lighter gas? It is going to be heavier. Oxygen is what? O2. Okay, O3 means what? More molecular mass. More molecular mass means heavier. So heavier gases are going to be closer to Earth's surface, or it is going to rise up? Closer to the Earth's surface. It is not going to rise up. So O3 is okay, trapped where? Trapped near to the surface. And when this is again inhaled, what will happen? We discuss, if you remember, we discuss O3 is not a, if you remember the stratospheric discussion, we discuss O3 is not a stable compound. Why it is not a stable compound? Octet is not complete. Remember, 3 ozones are there. Only 1 ozone octet is complete. The 2 ozone octet is not complete. It is not a stable compound. It is quite reactive in nature. So again, it reacts with your what? Hemoglobin and other thing, causing what? Causing nothing but problem. And that's why it is called as which type of smoke? Los Angeles or photochemical smoke. Fine. So that's why remember that this occurs when this occurs in the month of summer. When light is there, this light helps in breaking down. This light helps in breaking down and release of single O. This single O reacts with what? O2 to form what? O3. And as a result, you see this particular problem arise. Clear? Los Angeles is fire. Yeah, we have wildfire. Yeah, same place, same place. Los Angeles is California. Okay, it lies in California. You'll see a lot of your Hollywood movies and etc. where it is made from that. It was first observed over there. That's why named after that. Okay, it's not that London smog or sulfurous smog doesn't occur in India. It occurs in India also. But we discussed where you first observe it. It was in London because there you see industrial revolution, more burning of coal. More burning of coal means first there you observed it, and that's why named after that. That's why the USA become more urbanized city. More urbanized city means what? More vehicles are there. More vehicles means more vehicular pollution happened over there. So more vehicular pollution led to this type of smoke. Clear? So this was first observed over there. That's why named after that. Any doubt regarding Los Angeles smog? Any doubt regarding sulfurous smog? So this is what smog is all about. So smog can be divided into two parts: sulfurous smog and the photochemical smog. Smog is dangerous. Why it is dangerous? Health problem. Visibility is being reducing. So health problem is it is causing. Visibility also it is reducing. It also affects whom? It also affects the plants. Okay, when too much amount of smoke, dust are there, what will happen? Deposit on leaf surface and etc. When it deposit on leaf surface, what will happen? Photosynthesis process. It retards photosynthesis process, so it affects plants also. So that's why this smog is a problematic one. Fine. So this is all about what? This is all about your concept of smog, concept of fog, concept of dust particle, concept of haze, concept of mist. So now we are done with fog. We are done with fog, dew, white frost, mist, smog. Now next is what? Clouds. So now we are moving to the cloud concept. Fine. What is a cloud? How do you define this term? Condensed water vapor. Yes. Any other thing? Any other definition? Any other definition you can give? Huge body which contains water in the atmosphere. Fine. So cloud can be defined as what? Cloud can be defined as a many of ice crystals. Many of ice crystals which are present. Many of the ice crystals. So when water vapor condenses into these ice crystals, water vapor condenses into these ice crystals, it is going to form what? It is going to be formed it is going to form the clouds. Fine. Primarily based on shapes of the cloud, we classify cloud into 4 major types. We classify cloud into 4 major types. These are referred as a cirrus, cumulus. Then you also have stratus as well as nimbus. So based on based on cloud, based on the appearance or based on the shape, you classify clouds into 4 types: cirrus, cumulus, stratus and nimbus. Based on the height, so this is based on shape. Based on the height, you classify clouds into 3 types. There is high cloud, middle cloud and low clouds. Low clouds. So you will find high cloud, middle cloud and low cloud. These are something based on height. Fine. So what you see is you'll find the mixing of whom. In reality, you don't find cloud as it is. You sometimes see mixing of the cloud also happens. So that's why different type of different type of high cloud you can see. Like cirrus, you can see this is one type of high cloud. Cirrocumulus, cirrostratus. These are the high cloud. Middle clouds are generally altocumulus, altostratus. Altostratus. Low clouds are what? Low clouds are what? Low clouds are the nimbus, or you can write nimbostratus. Nimbostratus. Then stratocumulus. Stratocumulus. These are examples of what? These are examples of low cloud. Then you have one more cloud which is called as a vertical cloud because their extension is more. For example, your cumulonimbus clouds. Cumulonimbus cloud, which are known for their vertical extension, vertical clouds. Clear? So generally, high clouds are what? High clouds are formed above what? Above 6 kilometers. Above 6 kilometer, generally high clouds are there. Generally between 4 to 7 kilometers, you will find middle cloud. And around 3 kilometer, less than 3 kilometer, you're going to find the low clouds. Fine. So as we discussed, clouds are classified based on what? Clouds are classified based on cirrus shape. Based on shape, they can be classified into cumulus, stratus and nimbus. Based on height, they can be classified into high cloud, middle cloud, low cloud and vertical cloud. Fine. So which type of clouds are cirrus cloud? We say cirrus are having feathery appearance. Which type of appearance they have? Which type of shape they have? Feathery appearance. Like you'll see feather, no? So like you see feathery appearance. When cloud has such type of appearance, feathery appearance, then it is going to be called as what? It is going to be called as a cirrus cloud. Cumulus cloud resembles your cotton wool. Okay, it resembles your cotton wool. Cumulus clouds are resembling your cotton wool. Clear? And the stratus clouds are referred as a layered cloud. They are referred as what? Layered cloud. Clouds are appearing in various layers. These are referred as a layer cloud. Like this, okay? You're gonna find like this. Clouds appearing in various layers. When it is going to be appearing in various layers, then it is going to be called as what? Stratus cloud. And nimbus clouds are something that are referred as a dark, dense cloud. These are dark and dense cloud, which is responsible for rainfall. So which type of clouds are responsible for rainfall? It is nimbus cloud that are responsible for rainfall. Fine. So based on shape, you have these 4 classifications: cirrus, cumulus, stratus as well as nimbus. Cirrus means feathery appearance. Cumulus means what? Resembles like a cotton wool. Stratus means layered cloud. and nimbus means dark and dense clouds. So which type of clouds are going to produce rainfall? Which type of clouds are going to produce rainfall? As we discussed, nimbus has to be there. So which is producing rainfall? Your nimbostratus type of cloud or your cumulonimbus type of cloud. Clear? So we discussed based on what? Based on their height, you can have high cloud, middle cloud, and low cloud. But some clouds are okay. What? Some clouds, let's say this is a Earth surface. If within 3 kilometers are there, we call it as what? Low cloud. Then middle cloud. Then what will happen? High cloud. But if you have a cloud like this, which is extending like this, from the base till nothing but okay top, such type of clouds are referred as what? Such type of clouds are referred as a vertical cloud. So like cumulonimbus type of clouds is referred as a vertical clouds. Fine.
Cumulus and cumulus both are same.
Cumulus and cumulonimbus. No, they are cumulus is okay. We discussed cotton wool shape, and nimbus is what? The dark dense cloud. When both mix together, they forms what? Which type of cloud? Cumulonimbus type of cloud, vertical cloud. Fine. So in reality, you don't see these clouds appearing in what? Clouds appearing in alone. They generally mix with okay one or more cloud. So that's why they form cirrostratus or cirrocumulus or nimbostratus, stratocumulus. You'll see mixing of clouds happens. Okay, that's why we named it like this. Fine. So now this is basically you're finding clouds concept. So which type of clouds you are seeing? Cirrus clouds having feathery shape. These are having which type of shape? Feathery shape. Clear? Then which type of clouds are okay? Cumulonimbus. We discussed vertical cloud. These are extending from here to here. And we discussed when they are dark dense. Dark dense indicate which type of cloud? Nimbus cloud. Dark dense indicate which type of cloud? Nimbus cloud. Now, which type of clouds are cirrus clouds? Cirrus clouds resembles the cumulus clouds. Cumulus cloud resembles the cotton wool. They have a flat base, and like cotton wool, they will resembles. That is okay there. And stratus cloud, as we discussed, is a layered cloud. You can see this. This is okay. One cloud. So this is one layer of the cloud. So this is one layer of the cloud. You can see this is one layer of the cloud. This is another layer of the cloud. So when clouds are appearing in layer, then it is going to be called as which type of cloud? Stratus cloud. Fine. So these are different type of cloud that you are observing. Clear? And we discussed generally clouds in shape, they are not alone. They mix with other things. So that's why those clouds that are formed at what? Those clouds that are formed at a higher height. So those clouds that are formed at a higher height, they are going to be called what? Cirrus cloud, cirrostratus, and cirrocumulus. These are the examples we have written. Those clouds which are formed at what? At the middle level, that are referred as a altostratus and altocumulus, and those clouds that are formed at the lower level, that is nimbostratus, stratocumulus, cumulus. These are the clouds at the lower level, and this is vertical extension of the clouds. Okay, so just make this diagram. Just quickly make this diagram. Just show the what type of clouds are cirrus, cirrostratus. Stratus means what? A layer will happen. Layer will happen, but they will have a feathery shapes. That is why it is referred as a cirrostratus. Cumulus means cotton wool shape are going to be there. Clear? So that's why you just make a rough diagram of this one. So what we have discussed with regard to clouds are tiny crystals, tiny ice crystals, which is which is formed due to condensation. So cloud is formed due to what? Due to condensation process. Tiny ice crystals are going to be there. So here the cooling will happen above freezing point or below freezing point. If tiny ice crystals are being formed, it is going to be above freezing point or below freezing point. It is going to be below freezing point. Yes, sir. So ice, what is the definition for the cloud? Clouds are composed of tiny ice crystals which are formed due to what? Condensation of water vapor into ice below freezing points. Fine. Below freezing point. So this is important aspect you have to keep in mind with regard to clouds. Any doubt regarding this one? Yeah, stratocumulus also in lower level, nimbostratus also in lower level, cumulus is also in the lower level. All these are at lower level, all these are at higher level. Fine. Altocumulus and altostratus, these are middle clouds. This is cirrocumulus. Cirrocumulus. Yeah, height difference are there and size difference is slightly also there. It is more of a mixing of cirrus and cumulus cloud. So having certain feathery appearance also along with flat base. It is having more of flat base with more amount of bigger cloud. Fine. So how do you define cumulus cloud? How do you define cumulus cloud? Cumulus clouds are resembling which shape? Cotton wool shape. They have a flat base, and then you will see they always have a which type of base? Flat base they will have. Fine. How do you define cirrus? Having feathery appearance. Generally you'll find what? You'll find it at higher level, that is at the higher height, cirrus cloud. Then you'll also find which type of cloud? Nimbus. Nimbus are what? Dark dense cloud that you find with regard to nimbus cloud. Fine. And you have which type of cloud? Cumulonimbus type of cloud. Fine. Stratus clouds are examples of layered cloud. They are layered cloud formed one layer above the other layer. Fine. Now, what you are finding is, you are finding this cloud, which is cumulonimbus, called as a vertical cloud, and you also have this cloud, which is a nimbus cloud, nimbostratus cloud. You are seeing these two clouds are producing what? Producing the rainfall. These clouds are something that are producing the rainfall. So as we discussed, rain clouds are which cloud? Nimbus cloud. Nimbus cloud need to be there, then it is going to be called as a rain cloud. So rain clouds are which type of cloud? Nimbus cloud. So you are finding two type of what? You are finding two type of clouds. You are finding two type of clouds. One is like this, that is nimbostratus, and one is like this, which is what? Which is a cumulonimbus. Now, when this type of clouds are going to form, what will happen? When this type of clouds are going to form, what will happen? As we discussed, rainfall will happen, because these are nimbus cloud, rain bearing cloud. So they will produce a rainfall. But what will be there in the distinction? What will be there in the distinction? What distinction will be there in the rainfall? Because both are going to produce rainfall. Clear? Both are nimbus cloud, both are going to produce rainfall. What will be the distinction that you find in the rainfall? Continuous. Any other thing? Any other thing? As we discussed, this cloud is going to produce rainfall in a localized area. They are going to produce rainfall in a localized area. Their extension is what? Their extension is local. These clouds are going to produce rainfall in a very wide area. These clouds are going to produce rainfall in a wide area, while these clouds are going to produce rainfall in a small area. So all the moisture, you can see it is a vertical cloud, so can contain what? More amount of moisture. Can contain more amount of moisture. All this rainfall, all this moisture, all this cloud, whatever the tiny droplets are present, all will fall. So heavy rainfall will happen in a localized area. Heavy rainfall happens in a localized area, while here you'll see rainfall is what? Rainfall will not be much heavy, because it is distributed over wide area. It is distributed over wide area. Fine. Fine. In equatorial region we discussed convectional current what? Rises up. We discussed they produces what? They produces rainfall. So generally which type of clouds are being formed over there? Vertical clouds. Okay, because convectional current, you see the air is rising. When air is rising, you'll see formation of which type of cloud? Vertical clouds over there. Fine. So rainfall will be more in a localized area if cumulonimbus clouds are formed. If nimbostratus or cloud are formed, then rainfall will be distributed widely over a large area. Fine. Clear? So if you are going through the news, yesterday what had happened in Uttarkashi? Cloud burst had happened. Which type of cloud bursting? You'll see cumulonimbus type of cloud. Which type of cloud burst generally happens? Cumulonimbus type of cloud burst that produces heavy rainfall in what? Heavy rainfall in a certain area, localized area, causing lot of destructions. Okay, fine. So that's why you'll see you can see this news. What is cloud burst? The rare and intense weather blamed for India's what? The rare and intense weather event blamed for India's deadly flood. Clear? So you can see this is okay. What? This is a cloud burst phenomena that is okay happening. What is triggered in Uttarakhand? It has been triggered. What is the definition for cloud burst? IMD said that over the previous 24-hour extreme rainfall of how much had happened? 210 mm has happened. Clear? So this is okay. What? So this definition is there with regard to cloud burst. Just note it down. Meteorologists define India cloud burst as an event which is concentrated over 30 square kilometer or less. So less area, more rainfall. How much rainfall? More than 100 millimeter of rainfall. So area should be less than how much? 30 square kilometer. Rainfall should be more than how much? 100 millimeter. How much rainfall had happened over here? 210 millimeter. Much more than, okay, what? Much more than what is the minimum we have kept. Clear? So if in a localized area you are seeing more amount of intense rainfall, that is going to be called as what? That is going to be called as a cloud burst. In mains examination, you can get this type of question, because cloud burst news, Uttarkashi district. So what is cloud burst? How to control cloud burst? What are the disasters that can occur due to cloud burst? Those type of questions you will get in the mains examination. Fine. So remember this definition. Cloud burst is an event where, okay, what is happening? Where the rainfall is going to be what? Rainfall is going to be more than 100 mm, and rainfall should be concentrated how much? In a 30 square kilometer or less. Fine.
So it is mentioned 24 hours extreme rainfall.
This is in Uttarkashi what had happened.
But cloud burst will happen only for less than an hour.
No, rainfall can happen around 24 hours. No, When you have more amount of tiny crystal, when you have cloud contains more amount of what?
But cloudburst, when it happens,
Hmm.
then water will fall at a time. If water
Entire water will fall at a time, but if what will happen is, okay, if more amount of what tiny crystals or more amount of ice are there, then all will take time to fall, no? Like it is a vertical cloud. It is a vertical cloud like this. First, which will fall? If cloud burst happens, what will happen? Cloud burst means what? The cloud is not able to hold the moisture. That is, okay, what? Moisture is now coming down, or whatever ice is there, it is now coming down. First, which ice will come to the earth's surface? One which is closer to the earth's surface, no? So one which is closer will fall first. One which is away, then what will happen? It will take time to come down. That is okay there. So that's why you'll see, okay, the rainfall can be what? Rainfall can be heavy for a long period of time.
entire must be not for at a time. It will take
Bursting means what? Like, let's say we are saying that this is, okay, what? This is the scenario. Cloud is holding the moisture. Suddenly what will happen? It bursts. So what will happen? First, which will fall? Which is near to the surface, and which will take time to fall, which is away from nothing but, okay, surface. So that is what happens. Bursting of cloud doesn't mean, okay, what? Bursting of cloud doesn't mean that everything is falling together. Bursting of cloud means what? Cloud is not able to hold moisture. As a result, cloud is, okay, what? You know that gravity is attracting what? Gravity is attracting these tiny crystals. So what is happening is these tiny crystals are there, but gravity is attracting these tiny crystals. Clear? So till the time the cloud is able to hold this, what will happen? They'll be remain in that shape. If they will not be able to hold, what will happen? This ice will starts to come down, and that is what we call as the rain. Clear? So why rainfall is happening? Because of the gravity. Because of the gravity pulling the ice crystal, that is okay there. Clear? Any doubt regarding this one? So this water, this ice will starts to come down. When it starts to come down, what will happen? Temperature will increase as you are coming near to the earth's surface. This ice will melt into water, and that's why you see rainfall in the form of what? Rainfall in the form of water. That is okay there. Clear? Any doubt regarding this one? So this term you keep in mind. IMD define cloudburst as how event when this much rainfall happen in, okay, what? In a less area. And why this cloudburst occurred? Which type of cloud will create a cloudburst? Vertical cloud or cumulonimbus type of cloud. Clear? So when you are reading cloudburst event in Uttarkashi, you have to read it from what? Geographical perspective. How UPSC can ask a question on cloudburst, or how UPSC can ask questions on disaster management. So you have to mention about which type of cloud is bursting, which type of, okay, what? Which type of, what is the definition for cloud burst, what impact it is going to have. So all these phenomena you need to nothing but, okay, read it. Fine.
So is there any particular place of this cloudburst?
It's not particular place, but this is more common in mountain areas. Why?
They come travel to others.
Yeah, we discussed last class, okay, the concept of what? Concept of wind get blocked. When wind get blocked, wind is forced to rise up. When wind is forced to rise up, what will happen? Vertical clouds are going to be formed. Clear? So this can happen. This vertical type of clouds are more there in the, okay, the mountainous region because of blocking of wind by wind by the mountains. As a result, wind is forced to rise up. As it rises up, it cools and condenses, and vertical clouds are going to be formed. So in Himachal Pradesh, in case of, okay, what? In case of Uttarakhand, in case of, okay, the Sikkim, you'll see often, okay, news of cloud burst is going to come because these are the mountainous zone. Fine, but it can form also in other region, like in equatorial region we discussed, where intense heating are happening, the air is rising. There also you can see vertical clouds can form, cumulonimbus type of clouds can form. There also cloud burst can occur. Fine, but it is more common in these regions. Fine. So clear regarding what type of questions can be formed regarding Uttarkashi. So remember that concept of cloud burst. What is cloud burst? And what is the phenomena of cloud burst? Just remember that. And we discussed what? We discussed that why cloud burst occur. It occurs cumulonimbus type of cloud. So just remember that. Which are rain bearing cloud? Nimbus cloud are rain bearing. There are two type of nimbus cloud, nimbostratus and cumulonimbus. Nimbostratus are what? Horizontal cloud, they create rainfall, but this rainfall is distributed over a wide area. Cumulonimbus clouds are what? They are creating rainfall in a vertical cloud. They are creating rainfall in a small localized areas. Clear? Heavy rainfall. So generally when cyclone occurs, you see rainfall happens in a small areas. Okay, so there also formation of which type of clouds are there? Cumulonimbus type of clouds are there, vertical clouds are there. So those things you have to keep in mind. Fine. So this is all about concept of clouds. Now we are moving towards what? We are moving towards concept of precipitation. So now we are done with what? We are done with evaporation. We are done with the condensation part. Now next comes what? Precipitation. So precipitation is what? When the tiny ice crystal present in clouds becomes bigger or coalesce together, then under the influence of gravity, they starts to come down, which is referred as precipitation. So tiny ice crystal present in cloud becomes bigger or coalesce together. Then under the influence of gravity, they starts to come down, which is referred as what? Which is referred as a precipitation. Clear? So when we discussed, this is how clouds are there. These are the small tiny crystals that are present. When they collide with each other, they can become more bigger. When they become more bigger, what will happen? Under the influence of gravity, they starts to come down, which is referred as what? Which is referred as a precipitation. Clear? So cloud, when they are not able to hold this tiny ice crystal, what will happen? This tiny ice crystal starts to come down, and these are referred as what? These are referred as a precipitation. There are different type of precipitation. One is called as a convectional rainfall. The second type is referred as what? Orographic rainfall. And the third is referred as frontal rainfall. Fourth is referred as cyclonic rainfall. Different type of rainfall you can observe: convectional rainfall, orographic rainfall, frontal rainfall, cyclonic rainfall, and different forms of precipitation can be there. Different forms of precipitation can be there. They can be in the form of snow, sleet, freezing rain, water, hail. There can be different type of precipitation also. Fine. So different forms of precipitation and different types of precipitation. So convectional rainfall, orographic rainfall, frontal rainfall, cyclonic rainfall, these are different kind of precipitation. These are different forms of rain. As we discussed, water, rain may come down in the form of water, rain may come down in the form of bigger ice crystal, hail, snow, sleet, or freezing rain. Rain may come down in all these forms. So that's why different forms of precipitation are also there. Fine. What is convectional rainfall? What is a convectional rainfall? So convectional rainfall are in those areas where there is a intense heating. More amount of sunlights are there. Clear? Like in equatorial region, you're gonna find which type of rainfall? Convectional rainfall. So as we discussed, the equator receives more amount of sunlight, intense heating are there, earth's surface are heated. What will happen to air? Air in contact with the earth's surface also get heated. Fine. This heated air starts to rise up. As it rises up, what will happen? As you go up, what will happen? Temperature will decrease. Condensation happens. Cloud formation, which result in what? which result in rainfall. So this type of scenario happens in convectional rainfall. So convectional rainfalls are more seen where? More in the equatorial region, when there is a intense heating that happens. Because of intense heating, what will happen? You'll see the air get heated, air starts to rise up. As air rises up, temperature will decline, and this will result in what? This will result in rainfall. So in India, you have studied about a term called pre-monsoon shower. Okay, there is a term used, pre-monsoon shower. So as we discussed in India, in the month of March, April, May, sometimes you see rainfall, no? Sometimes you see rainfall in India in March, April, May. So that rainfall is occurring due to what? The convectional rainfall. Why? Because more in March, April, May, sun is shifting towards what? Sun is shifting towards Tropic of Cancer. When sun is shifting towards Tropic of Cancer, what will happen? India landmass will get heated. When landmass will get heated, what will happen? We'll see convectional rainfall can happen. Clear? So in India, this convectional rainfall are referred as what? Convectional rainfall are referred as a pre-monsoon shower. As we discussed, most of India's rainfall, more than 90% of India rainfall is concentrated between June, July to September, because this is a monsoonal period in India. So more than 90% of rainfall happens in this season. But before, before nothing but arrival of monsoon, there are certain rainfall happens in India. Those are called as what? Those are called as a convectional rainfall happening due to pre-monsoon showers. So whenever any area is heated more, you'll see what? Convectional current will rise up, which will create convectional rainfall. Fine. The second type of rainfall is called as a orographic rainfall. So orographic rainfalls are where you are going to see in the mountain areas. So just now we discussed moisture and leaden wind. If they comes, what will happen? They will get blocked. As a result, they will be forced to rise up. As you go up, what will happen? Temperature will decline. When temperature will decline, what will happen? We'll see a rainfall. We discussed this side of the mountain is referred as windward side, while this side of the mountain is referred as a leeward side. Clear? So such type of rainfall is referred as a orographic rainfall. That's why you will see more this area of India, coastal areas of India receiving more rainfall. Why they are receiving more rainfall? Because which mountain is there? Western Ghat. Western Ghat blocks the wind that is coming, and since Western Ghat block the wind coming, you'll see Mumbai and etc. receiving very high rainfall. But other side do not receive much rainfall because leeward side it is falling up. Clear? Any doubt regarding this one? So when rain bearing winds are blocked by nothing but the mountain, then it is going to be called as which type of rainfall? Orographic rainfall. Fine. Which one? We have written no last class onshore wind. Onshore wind means what? Those wind that are coming from land to sea towards land and containing moisture. Okay, so when onshore wind comes together and they are forced to be lifted by the mountain, then which type of rainfall happens? Orographic rainfall. So any doubt regarding convectional rainfall? Where do you see convectional rainfall? Where intense heating are going to happen? Generally in equatorial region, as we discussed in India, in summer month, you're going to see convectional rainfall. Where you're going to see orographic rainfall? Where mountainous areas are there. So in India, you are finding this orographic rainfall where? In this region. That is the reason why you find desert over here. Why we have a desert over here? Because Aravali does not block which type of wind? Monsoonal wind. Clear? Monsoonal wind is coming like this, but Aravali's is acting parallel to whom? Parallel to monsoonal wind. They are not blocking. Western Ghat is what? Western Ghat is blocking the monsoonal wind, but Aravali's is not blocking. When Aravali is not blocking, no orographic rainfall, and that's why what is happening? Desert region. Clear? So in India, desert regions, this desert region is found. Why? Because Aravali's are parallel to whom? Parallel to the monsoonal wind. Okay, they are acting parallel to the monsoonal wind. Fine.
So this
Orographic can happen any time also. If moist leaden winds are coming and they are forced to what? Nothing but uplifted by the mountain, then this type of rainfall can happen. Can happen in summer also, can happen in winter also, can happen in monsoonal season also, like we have discussed. Clear? But these are these are more common during the summer month, because rate of evaporation is what? More. In summer you have more rate of evaporation, more moisture in the air. In winter you will have what? less moisture in the air because of less evaporation. So more common in case of summer month, but can happen all the time. It's not necessary that. Hmm.
But Tamil Nadu is the rain-shallow region.
Hmm.
And I think western is we combine into the humidity and getting the rainfall will up to
No. Tamil Nadu is over here. Westerlies blows where?
from the China.
We discussed subtropical high pressure belt too. Where westerlies blows? Subtropical high pressure belt to subpolar low pressure belt. Clear? So subtropical high pressure belt is this extension. India is extending from where to where? From 8 degree north to 37 degree north. We discussed from 23.5 to what? 23.5 to 35, you have subtropical high pressure belt. From here, what will happen? Westerlies will come. So westerlies is going to be there in the Tibetan plateau. Clear? It is going to be there in the Tibetan plateau. Fine. But westerlies is not going to blow where? In the Tamil Nadu, no? Here, which wind is blowing? Northeast trade wind. Northeast trade. Easterlies are blowing where? Easterlies are blowing in polar region. No? It is originating from polar region towards where? Subpolar region. Clear? We discussed westerlies are blowing from where? Which belt to which belt? From subtropical high pressure belt to subpolar low pressure belt. Clear? And easterlies are blowing from where to where? From polar high pressure belt to subpolar low pressure belt. Forgot pressure belt. This is pressure high, okay, polar high pressure belt. This is what? Subpolar low pressure belt. This is what? Subtropical high pressure belt. This is equatorial low pressure belt. So here which wind is flowing? Northeast trade wind. Here which wind is flowing? Westerlies. Here which wind is flowing? Easterlies. So westerlies are going to blow in this region. Westerlies are not going to blow in Tamil Nadu. Where which wind is going to come? Northeast trade wind.
So due to that, Tamil Nadu will get rain.
Yeah, Tamil Nadu get rain due to northeast trade wind. When northeast trade wind moves like this, no? Northeast trade wind moves like this. So when this northeast trade wind move over Bay of Bengal, they pick up moisture and they create rainfall where? They can create rainfall in the Tamil Nadu. Normally, northeast trade wind are land to sea. They are moving from land towards nothing but okay sea, so they don't create rainfall. Clear? They are moving like this, so they are moving from land to sea. Don't create rainfall. But when the northeast wind are moving from, let's say, like this. So we discussed this is offshore wind. This is offshore wind. They don't create much of rainfall. That is okay there. Some northeastern wind can coming from China. They when blow over Bay of Bengal, pick up moisture and they create rainfall where? In the Tamil Nadu region. Clear? Any doubt regarding this one?
From the northeast trade goods which are coming from China.
Yeah, they pick up the moisture from Bay of Bengal and create rainfall over there. So it is not due to westerlies rainfall. Tamil Nadu is getting rainfall. Clear? Northeast trade wind. Clear?
That is what we post summer, no post monsoon.
Yeah, post monsoon. This not like currently we have which type of wind? Southwest monsoonal wind. No, currently we are monsoon season. So southwest monsoonal wind will blow when shifting of pressure belt. Last class we discussed shifting of pressure belt. No, so when shifting of pressure belt means what? When equatorial low pressure belt shift over here, what will happen? Now we discuss the southeast has to cross the equator. When they cross the equator, they will be deflected towards which side? Right hand side due to Coriolis force. They become which type of wind? Southwest monsoonal wind. Clear? But because this pressure belt shift. This pressure belt, equatorial low pressure belt shift from here to here. Why equatorial low pressure belt shift? Because sun is where? At the Tropic of Cancer. So when sun is at Tropic of Cancer, this region will get more amount of heat. When this region get more amount of heat, what will happen? Low pressure here will be created. Now we discuss it is a zone of meeting of which two wind? Northeast and southeast. So southeast has to cross the equator. They will be deflected towards right hand side and become southwest monsoonal wind. Clear? So northeast at this time, northeast wind is not blowing over Tamil Nadu, because northeast wind is only blowing up to here, not over Tamil Nadu. Clear? When the sun rays? Low pressure means what? Low pressure means expansion. No, low pressure means expansion. So sun rays is falling means what will happen? Come down means what? Low pressure is formed when air is rising up. That is low pressure. Low pressure means what? Expansion is happening, air is rising up. High pressure is going to form when the air is coming down, compression is happening, then okay, what will happen? High pressure are going to be formed. So when the air is coming down, high pressure is going to be there. Low pressure is not going to be there. No, low pressure will form when the air will rise up. That's when low pressures are going to be formed. Clear? So when sun is heating this area, what will happen? Air get heated. Heated means expansion will happen. Expansion means air will rise up. Low pressure are going to be formed. Clear? So last class we discussed whenever heating happens, what is formed? Low pressure. Whenever cooling happens, what is formed? High pressure. So here, because of heating, low pressure is going to form. So this is about two type of rainfall. That is, we have discussed frontal rainfall and convectional rainfall and orographic rainfall. Rest type of rainfall we'll take up in the next class. Fine. So we'll discuss okay the frontal, cyclonic, and all those form of precipitation, that is snow, sleet, we'll take up in the next class. Fine. Thank you. Thank you. Test papers checked, but I've not yet discussed because Pooja wants to write it. Okay, she wants to write. Okay, she'll not be writing. Okay, yesterday she told she'll be writing, so I have not discussed the paper. Let her write also, then I'll discuss. But if she's okay, not well, then we'll discuss tomorrow. Or I'll provide it tomorrow. Okay, discuss. Hmm? Anything you are telling?